4-84. Solve each of the following inequalities. Express the solutions algebraically and on a number line. Letter A. 3x minus 5 is less than or equal to 7. To solve this, we need to figure out what value of x is going to make this statement true. We know that this side of our inequality has to be less than or equal to 7. So here we go. First thing we can do, let's rewrite it so we have some room and we can see it. 3x minus 5 is less than or equal to 7. So let's just work on isolating x by undoing what we can. So let's add a 5 to each side. We're going to have, oh, that's a little uphill, sorry about that, but we can do it. 3x is less than or equal to 12. 3 times what number equals 12? We know it's going to be 4, but let's just go ahead and undo it anyway. Divided by 3, divided by 3. X should be less than or equal to 4. Now this is our algebraic way of showing our answer right there. We want to show it on a number line. We're going to need to draw our number line. And when I do it here, you don't need to have a million, points listed on here. I'm going to put my main point that I'm focused on is when x is 4, but you also want to give at least one value or two on either side of it, just so that people are sure, that you're sure that your number line is going the right way. You want to represent the answer correctly. So our boundary point here is 4, where x is 4. And since we have equals in here, that means that 4 is definitely going to be a solution, a value that works. So we want a closed circle in there. If we take 4 and we plugged it back in, it would make a true statement. In fact, let's do that. If we say that 3 times our 4, and we subtract 5 from it, it should be less than or equal to 7. Well, in this case, since we know that x is less than or equal to 4, we should get 7 on this side. 3 times 4 is 12. 12 minus 5 is less than or equal to 7. Well, 12 minus 5 is 7. So that is true. That's why we fill it in with a closed circle. Now we're talking about all the values that are less than or equal to 4. So we're thinking about all the numbers that are less than or equal to 4, which means we're talking about all the values on the number line going this direction. How do we check it? Well, let's just choose a point. We know that 3 is to the left of 4, 2, 1. I like to use 0 if 0 is available. That's an easy number to plug in. Let's check that by saying, we're going to say here 3 times 0 is going to be, when we take away 5, is going to be less than or equal to 7. 3 times 0 is 0. 0 minus 5 is negative 5. Negative 5 is less than 7. That is true, so we know that that is the correct answer. So this is our algebraic representation, and this is our representation on a number line. There's our answer for letter A. Actually, let's box these in there so that you can see. This is the algebraic answer, and then this is our number line. Letter B. We have x squared plus 6 is greater than 42. A couple ways this can be solved algebraically. We have an x squared term and we have no x terms. So x squared is our only variable. So we can either look to isolate our variable by getting x squared is greater than 36. And if we think about it, if this had been, say, x squared equaled 36, we know that x would have been -6 or +6. So those would have been our boundary points there. Well, now we're talking about we want it to be more than 36. We want it to be more than 36. So we're going to take it and we're going to say square root of x squared. We're going to take the square root of 36. We're going to have the absolute value of x is going to be more than 6. So think of values that would make this true. We know our boundary points are going to be at 6 and -6. And when we're taking it and we're looking at it on a number line, everybody's usually pretty good with that first one there. It's the second one that we tend to struggle with. They're like, what inequality has to go in here? Well, let's put our -6 on here. Let's put our +6. If x is greater than 6, we know this is an open circle. This is going to be an open circle. We just don't know which way it's going to go. Well, we want the numbers that are more than 6 units from 0. Well, if 0 is in between here, we know that everything less than 6 or greater than -6, these values here are all less than 6 units from 0. So we're looking to go outward like this. X is greater than 6 is right here, which means what would this inequality be? Talking about x is less than -6. How do we check? Well, let's just take values from either side here and plug them in. Let's use, I don't know, this value here. Let's use 7, and let's use a -7 to check. So we're going to say 7 squared plus 6 is greater than 42. 7 squared is 49 plus 6 would be 55, and 55 is greater than 42. That one works. Let's try -7. Well, if we put in -7, we know that we're going to end up with the same thing on this side, right? Because -7 squared, we'll still do it anyway, though, just to make sure everybody understands. That would be 49 plus 6 is greater than 42. That would also be 55 is greater than 42, which is true. So our answer here, x has got to be greater than 6, or let me clarify, this is not less than or equal to. So let me erase that here. I don't want anybody to get confused. There we go. And our number line is right here. So we have problem 4-84. X is less than or equal to 4, which we have here. We have x is greater than 6 or x is less than -6, in which case we have our open circles going in the opposite directions here. So Mr. Boyd, thank you for watching. I hope this helped you out. If you have questions, make sure you ask your teacher.